Good morning, good afternoon, good evening. It's 5 minutes to the hour. And to respect the people who have joined, we are going to start. So this is the East, Central, and South Africa Microsoft Excel Forum, brought to you by Crisp Excel. So if you want to support the webinars, please subscribe to our YouTube channel. Many of us are watching, but they are not subscribing. So today we have an interesting presenter, Conrad, and I have a small history about Conrad. Conrad is a self-taught analyst and BI developer with a background in marketing. He has a PhD in marketing. He stepped into the world of IT and analytics at the age of 30, and since then he has been building powerful reporting solutions using Tableau and Power BI. Outside his professional work, he is passionate about data science, enjoys diving into R, especially Tidyverse, as well as Python and SQL. The focus on solving real-world problems and sharing practical, easy-to-follow tutorials for others to grow their skills. So Conrad is BI and Dev R geek. If you're not following him on LinkedIn, he has very good R and Python solution for all the challenges that are out there. And he has a very interesting website called Numbers Allowed Us. I'll share these two links for us to join and also to visit. He's going to tell us about if he has any courses that he can sell or if people want to be trained by him. The topic for today is from spreadsheets to scripts, a gentle introduction to R for Excel users. So, Conrad.
Okay. Good morning. Good. Oh, I think there is nobody with a morning right now. So good evening, good afternoon, everybody. My name is Conrad. I'm the, as Crispo said, self-taught analyst with about 10 years of experience right now. Usually with Tableau and Power BI, so with the business intelligence tools. But outside of this, I have also my own side projects like this website product numbers around us, which are focused on my other topics of interest like SQL or R or Python. But my most favorite tool is R. What is R? Why is R, and why there is me in R? It sounds like like citation from the Marvel movie, but what is R? R is a scripting language of fourth generation of programming languages that was developed not for programmers, not for data scientists, but for biostatisticians. They have a different approach to the programming, the different approach to the using of code. And that's why some people who are data scientists, and I talk to them about the R, they are not treating it like proper language. But probably, as you will see, it's much more proper for people who are not into the data science, in the deep knowledge of data science, but who knows how they want to proceed their research or analysis. Why R? I just told you that it's fourth generation language. Levels of languages in data science means that the first level is the most complicated for human to read, but the fastest to read by computer. Then, if you have you're going up the stairs, you have more abstract language is more abstract to computer, but more readable to people. So the higher the number of generation, people can much more easily read it, but at the cost of translating this language down to the 0 and 1s for computer. And why I choose this for level? Because they are usually specialized for certain purpose. For example, for level is SQL, which is that database. It's not a programming language; it's a query language. For example, all markup languages like HTML and so on, they are still languages, but they're not programming languages. They're like purpose-specific languages. And why me in R? As I started with BI, at one moment I realized that not everything can be done in these tools, either Power BI or Tableau. Excel was again not really helpful as well because the structure of calculations. So I tried 2 languages that are scripting languages used in analytics, Python and R. And R was much more friendly to read, much more friendly to write, because it's like mimicking the way of what we were thinking, of what we are thinking. And of course, one of the reasons was that unlike SAS and similar things, R and Python are open source, so you can use it freely, and you can use it either commercially or for fun, even at home. There are 3 main ways to code in R. The base R, so this first way that was developed by the creators. By the way, this year in October there will be 25 years from the moment when R was invented. It was based on the previous language called S. They like the single letter languages, right? The second one is Tidyverse that I like the most, and that's why I put the star on it. And the third one, data table, it's much more optimized for faster calculations, but it have less friendly syntax of writing. What can I say about the Tidyverse and main principle about, around Tidyverse? It's all about the tidy data. You can say, okay, we have tables. Just like in Excel, we have tables. But the tables in the tidy data, they can be done with Excel or any other tool. Tidy data have variables as columns, observations as rows, and values as cells. So there cannot be cases like merged cells or merged headers or headers in the rows merged. For example, also if we have table pivoted for having the years in the columns, they are pivoted, but they are not tidy anymore. We can call it untidy, and in many cases it's very important part of the calculation, But the first thing we want to have in the first place, when we are starting everything, we have to take care about the tidy data. What is the other characteristics of the Tidyverse way? It's a operation called piping. If somebody of you are familiar with Python, it also have equivalent in Python called method chaining. And I want to show you how we can write the code in R. Those three elements, one in here, one liner, one on the bottom with indentation, and one on the right with a piping. As you can see, the top version on the left can be familiar to you, because that's how you're writing calculations in Excel, in a Power Query, sometimes even in many other languages. But to understand this notation, we have to look which pair of parentheses is in the deepest level, right? So it's not really friendly to read and comprehend. Much more if we are gonna do the enters and indentations on the bottom, because we can see when we look in our indentation, we know where is the core of the calculations. All three of these calculations are written with the same filter, with the same functions from the Tidyverse framework, but each one is much more. They differ in the ability to comprehend what's going on here. On the right side, we have piping. So this set of characters, percent greater than percent, is called pipe. There is much more pipes in the R, but this one was the first one used, and much more. So far, most common of in usage. And as I can say you now that we see here how exactly we are thinking in the process. But let's go here. How to read it? Pipe mean and then. So we are taking data frame and then filter rows when column values greater than 10, and then create new column double value, which will be equal column value times 2. And then group everything using variable group, and then summarize to variable total, summing all double values, and then sort all using total column descending. So we have exactly from the top to the bottom way how we are proceeding in our operation. There is some nuances that can be introduced. For example, we have one type of pipe that can be like branching of this pipe, but it's nuanced and much more much more difficult thing, and much less used. So what is the Tidyverse itself? Tidyverse is a so-called meta package. It's like a collection of packages that are used for data manipulations, structure manipulations, and so on. Every single package is focused on one type of manipulations of one type of calculation. So we can load different packages separately, or just load Tidyverse itself, and it will like load all the Tidyverse together. It's like Swiss knife of analytics, because we can do almost everything we can think about in a descriptive analysis or just making transformations. So some of the main packages that we use in Tidyverse are ggplot, which is very unique way. It's a very unique way of constructing plots. The two first letters are coming from grammar of graphic. There was I don't remember right now the author of the book about grammar of graphics, but it looks on the chat building like on laying the layers of the chart. So we have canvas, then we can add layer of points, that we can add layer of lines, and so on, colors, and so on. I will show you one example there a little bit later. Then we have dplyr. Dplyr's functions are exactly here. The main and more the most used functions of dplyr are filter, mutate, group by, summarize, select, arrange, and I would say that these six functions are almost like in Pareto ratio, almost 80% of all calculations. Then we have tidyr. Like the name said, it's for tidying. So, for example, there are the functions that are used to pivot or unpivot data if there is a need for this. There are also things like separating columns. For example, if you had the column with country and year as a one cell, right? Just with a space between, we can use function separate this column, and we are talking separate this column by the space and create columns of this name. The following three are, for example, POR, the functional programming. That's one of my favorite discoveries in R, but not the really beginner stuff. I think that all of you have at least one encountered something called loops. So repeating calculations, repeating operations more than one time on the different elements. In POR, we are not looping. We are just like, for every row of the data frame, we're giving this row instruction, do it. We are not going one row, do it, one row, do it, one row, do it. All of them take the same instruction at the first moment, and they are doing much faster than loops. And they are usually called maps. So we are mapping the function on all data frame, on all rows. But it's a little bit more advanced concept, this functional programming. Then we have, for example, stringer. As you see, they usually are at the end of packages to distinguish it. Stringer is a package that is focused on the text manipulation. As I have seen last year, somehow in last year, the regex functions were introduced in Excel, right? Here you have all the functions about regex as well, but you can also use the functions of stringer as some kind of wrapper of the regex. So we have function starts with or string sub. So the string str sub. So subset the string. We are giving first like with Excel functions left and right for the substring for subsetting the strings. And the last one I put here, but there are many more specialized packages, is LibraryDate, which can be very useful if we are making operations on date time, date, months. It have so-called time arithmetics. So if we have days, we can simply add 4 days, add 3 months, and so on and so on. It has the more advanced concepts like interval objects and so on, but just to show what are the packages, I just mentioned this one. What I used the stringer this LibraryDate packages in less advanced cases. For example, it have the function wday, so it's shorter for weekday. And if we put correct, if we make the arguments in this function correctly, we can take from the date not only which in the order in week this day is, so 1 to 7, but we can also have like abbreviated name of this weekday in any locally. So in French, in Polish, in English, Russian, whatever language you can find in your locally on your computer. But what can I say about the R more? That analytics is what it was its first purpose, but it's not the last purpose, and much more things can be done with R. So we can make reproducible reports with one construction and only settings, some parameters. We can make tons of reports in some for example 2 or 3 clicks. A few years ago there comes the RShiny framework for R that can be used for make web apps. These web apps can also be the analytical tools with simulations and so on. We can build APIs. We can scrap the websites. We can use the machine learning algorithms and forecasting. I used R for forecasting in my previous company, and it was really nice way nice and easy way to forecast and to make it many consecutive times in a row. And what is the most what is closest to Excel as it is, there is a integration of R and Python, of course, in Power BI and Power Query. So in Power Query M calculations, we can include the R scripts. And there is also the possibility to make visualizations based on R, and of course Python in the Power BI. You may think that, as I said, that I didn't use the Excel so far in my work extensively, because I get to know R. I can be perceived as a heretic for you. I used Excel only for input and output of data. R gave me opportunities, gave me functionalities that I wouldn't do in Excel in such a fast pace. And what can we do more? Because we can go into the RStudio. I can spare you the long story because I will not show you how to install RStudio. Of course, RStudio is my default editor and IDE for R, but there are more. For example, right now, our consortium POSIT, which was before our consortium, the company, the foundation that is taking care about our language. They are also working on the second IDE called Positron, which can be used not only for R, but also for Python, because there is a way of thinking in the scripting languages environments that we have to not fighting what is better, R or Python, but to take all the best things from the one or the other languages, and they are working on how to make it more cohesive with each other. They can be. There are some ways that can be using both technologies at once. For example, Jupyter notebooks or markup R marked up markdown notebooks, or something like Quarto, which is independent from either R or Python. And what we have here, unlike the many IDEs, we have something crafted exactly for our usage. But of course, we can also make another type of files. For example, we can edit C files, C++ files, HTML, CSS, shell scripts, SQL scripts, and so on and so on. But main purpose of the RStudio is, of course, writing in R. We have console at the bottom. We have environment on the left. It's my setup. It can be placed everything in the different positions. We can see the files like the File Explorer here. We can see the packages, all the packages I have installed. If they are checked, they are loaded. Like here, I have already loaded these two. We can see the presentation. If we are doing presentation, I rarely use it. We have also viewer. So if we make, for example, plots, they're going here. And if we are working, for example, with databases, that is also available in RStudio. We are defining it here. Why I am focusing on the environment here? Because unlike in Python and many other languages, we don't have to run all the script together to get the results. We have much more so-called interactivity in here, because we can run even line by line. We have Gapminder is loaded. We have the Tidyverse, they are loaded, so they are just showing here. We have we will use the dataset called Gapminder that was used a few years ago, but Hans Rosling on the famous movie on the YouTube about the life expectancy and so on. It's available for R in the Gapminder library. It contains data from 1952 to 2007 about life expectancy, GPT per capita, and population in about 140 countries. And after each point I'm gonna go through, I would like for you to answer yourself, or even me on the chat. Does our way need more effort than the same effect in Excel or even or any other technology you think about? So we had this data Gapminder. I will use I can use this run button here, but as you see, there is a shortcut, Control and Enter, and we have the environment. If we click here, we can go inside and look at the data. That's not really possible in many other IDEs and in many other languages. So how do we get the data from the most recent year? As I told you, the most recent year is 2007. So let me call it GAP 2007. I have Copilot, so it's already showing me the way, but I will write it a little bit another way. And here we are. We have Gapminder and then filter the year 2007. Why we have the two equals sign? Because one equals sign is exactly like this arrow. It means assigning. It's assigning operator, not comparison operator. So if we run this script, these two lines, we can also, of course, get here. Not the Gapminder. So what? Double M. And we have 142 observations for year 2007. Then, in which countries we have, maybe I'll enable this for a moment, just to have more fun. Which countries in 2007 had the highest life expectancy? For example, if we want 10 countries with the highest life expectancy, we're going to take the GAP 2007 the data frame which is already in the environment. So let us call this top 10 LLE, life expectancy 207. Of course, we should use much more meaningful names, but for this sake, I will use like more cryptic one to have it faster. Gap 27. Then we're gonna sort all of this in the descending order by life expectancy column. So we are gonna arrange descending and life expectancy as a column. Okay, we can run it now, but we are still having 142. So next step, and then we are gonna select. We're gonna take only 10 of them. So there is a function called slice max. So give us from the arranged table, give us only 10 highest values. N argument is for giving the number of the rows we have we want to get back. Thereby, on the console, it shows me that we need order by, so we need order by life experience. And now we have 10 with the highest life expectancy in 207. But we want only the countries, and for example, just the value of life expectancy. So we need to take select, which means get the column with country and life expectancy. And we have data frame with dimensions of 10 by 2. So the most the highest value in the world in 2007 was for Japan 82 years, and the 10th place was Canada. Does higher GBT per capita imply higher life expectancy? We can do, of course, much more difficult things like linear regression, but we can also see it on the graph. So let's go with the ggplot. We are layering first layer with a function ggplot, and then for data we're taking gap 207, and for aesthetics, AES for the shorter, for x-axis we're taking GDP per capita. For y-axis we are taking life expectancy, and for example, for color we can give continent, because we have such column in the data. If we run this, we're showing only the canvas, only the axis and canvas in the middle. So what we are going to add? We are not adding the pipe, because it's mean and then. In here in ggplot we have adding the layers, so we are just putting plus. Then we are adding the geoms, so-called. So we have geoms, as you see on the drop down. We have AB lines, areas, bars, and so on and so on. Box plots, contours, but we are using point for this purpose. For example, with size, we have much more things to customize here. So I am only adding, for example, size, and if we have the color on the aesthetics, we can also add alpha, so it means transparency. Let's do it 07, so it means 70%. And we have all 142 countries on the graph. We can see how much one implies another, and we can see which continents had the highest, which had the lowest life expectancy. And we, of course, don't really like this life exp here and GDP per cap here. There is no other information what this chart is about. So we can also add labs function that we can define in which we can define the for example, titles. We can add the x-axis label. On X we have GDP per capita. And on Y we have life expectancy. It's much more informative, not so many cryptic elements. And one more thing that we can do here, for example, we can change the scale for the GDP per capita, because we have very scrambled points on the left side and very long tail on the right side. So we can use scale x log 10. Just make the logarithmic axis to have it more dispersed, but still readable. But what can we do next? The summarizing of all the things is one of these things. For example, we want to know what is life expectancy for 2007 for each continent, and so we're starting with GAP 2007. Life expectancy per continent. So GAP 2007, we can group it by continent, and then summarize and we will not get 142 points rows of data. We're gonna have only 7, I think. For example, we can add 2 summarizing variables: average life expectancy. So it would be mean life expectancy and average GDP. Mean GDP per capita. Usually, I'm adding here one more argument, NA RM true, because if we have not really clean data set, if we have NAs in the column, it's gonna break the calculations. If we're gonna add this one, it just doesn't count the NAs. So what we have here, life expectancy, continent should be from the lower case. And we have, well, 5, because Americas are together. So we have all continents averages, GDP and LE in here. And last example I prepared for you is to make how the life expectancy has changed over time with 3 or 4 countries of your choice. You can add the countries right now, or I can use those I prepared so far. Okay, so I will do with my choice, and so we're gonna go. We're gonna link 2 things. One with the single pipeline, and then plotting in the same pipeline. So we're gonna take all Gapminder data set. We're gonna filter the country in, for example, Kenya, from Africa, Iran, from maybe Poland, from Europe, and Brazil. Let it be Brazil. One representation from each of the continents. So we have like 40 to 48 rows of data. Then we're gonna put it into ggplot. One thing to know with a pipe, down below it works like take what we have before, for example this part of data, as a first argument for the next function. So as you were seeing here, I add as a first argument gap 207, but here I piped this data set filtered into ggplot, so I don't need to add it. And we are going straight to the, but it's just a nuance that can be treated like a trick. So we are taking year for x-axis, then we are taking y for life expectancy, then we are going to color for country, and we have data right now, of course layers, then not the pipe. Then we are going to add geom line line can have different arguments as well. I will add, for example, line size, which means the broad of the line for 1.3, and just for being aesthetic, lab, and we have live. For title, we were gonna put life expectancy over time. For X, there will be year. And for example, we can add from 1952 to 207. And for Y, we're gonna have life expectancy. And run. And we have this the plot of the life expectancy changing over the time. And as you see on the console, I have some kind of message here. Using sign was deprecated in the one of the previous versions of ggplot. So the more correct would be line width. It is the same, but much more correct. And if we want to take this plot, for example, we can save it as image, save it as PDF. There are many possibilities to make it. We can also take it into another window. It's rescaling itself, so if you like it more scrambled, more widened, it's all about your preference. And now we have possibility to save images, for example, JPG. And as I see, we are over the hour, but do you have if we have a few more minutes?
Yeah, we can continue. We can continue. Okay.
Do you have any other interesting ideas what we can do with this data set? Or I maybe should go on the chat. So
yeah,
what's the difference between summaries and reframe? Reframe is one of the newest functions already, and it's the redefinition of the table. I rarely use it, but summarizing is like how to say it, to aggregate it on the level of the it's aggregating as a final step of the calculation, because of course after summarizing we can make, for example, another aggregation, but summarizing is much more comprehensible for beginners, and usually it stays with the coders for further what can I say, coding. If you have any other ideas what we can do, we can make some changes, we can make some experiments here. If not, I will just I just want to encourage you to try. If you would like to read some things about R on my blog, on the numbers around us, there are many articles that are made a little bit like metaphorical. For example, I'm showing the usage of one of the packages as cooking. So it's sometimes it's much more friendly to comprehend things when they are metaphorically told about differently. So I can also you can also find me on LinkedIn, contact me, write to me if I will be if I will have knowledge enough knowledge to help you, or I can help you start with R. I'm all for you for your help. And sorry if I'm just if my pace of speech just sometimes just stops because of lack of words.
No, it's okay. I think this is an interesting webinar for me because I don't have any knowledge of R. There's a question first from Ahmad. He is asking, what's the difference between summarize and reframe?
Yeah, I already answered, but I can do it once more. Summarize is like aggregating, and reframe is a red definition of the data frame for aggregation, but also for different purposes. Its newest, the newer version, newer function. I'm not really using it very often. I'm rather sticking with the summarize if it's not gonna be the slower or the longer way to do it.
Okay. PK is asking, is this data set appropriate for forecasting, and can you quickly demonstrate? Is it appropriate for forecasting?
I don't know if I have data for forecasting right now because it's my private computer. But
I think what he's asking for is like you see, like the way I'm surprised with Kenya life expectancy now, based on what you have observed from 1950 to 2000. Can you forecast, like in the next 10 years, if the trend continues, where the country will be?
Okay, we can try it, but I need to check if I have a package for this.
Okay.
My most favorite package for forecasting was developed by Facebook Labs, and it's called Prophet. And I didn't use it for some time, but I can try to make it. I'll just for my own reminder, I will open the documentation.
Okay. As you do that, there's someone asking, and it was also my question, do you have export to Excel for the results? Is there
Of course.
Oh, okay. Okay.
We can export to Excel, CSV, whatever you want.
Okay.
I didn't show any importing or exporting yet, but it all can be done as well.
Oh, okay. Maybe that's something you may need to show how to import, because I'm thinking if you have data with more than 2 million rows, how do you import and you do your analysis and then you export it back to Excel?
So maybe I will show you the importing and exporting first,
okay.
because it's gonna be much faster to do.
Okay.
For example, in environment here we have import dataset.
Okay.
We can use the base importing, like here, for example. It's gonna use the it's gonna take the CSV files or so on. And we have reader package, which also comes from the Tidyverse. And do I have any file that I can read right now? Okay, I think I can use this one, but it's Excel. So let's get back. It's for CSV. We have from Excel. I will take the documents, diamond sample. It's coming here. We can also add we can choose the type of data we have here, for example, because sometimes it's not reading correctly. And if we know it, it's probably the first place when we can do it. We can in here in import options, we can define how it will be called in environment, which fits of the Excel we are using, or the range of the cells, how many rows, how many top rows we are skipping. If we are using the first row as headers, and we're just importing this here. And for example, if you want to export it, we have write to Excel, write. I have package read Excel, I think.
I see write.csv. I don't know whether that's the same thing.
Right. If we want, for example, I can show you one more thing. If we know what package the function is in, we can go with the package first and 2 columns. Then we have functions from these columns. And this one, no, read Excel didn't have it. Right, Excel? Right, Excel XLSX. For example, we have diamonds X sample, and we're gonna save it as diamonds for not to complicate anything. XLSX, and it's gonna be written in the right place where we are here. We're now, so in the folder Crispo webinar, and we have it here. And the same things would be with a CSV, or maybe I can even tell you show you one more thing, because almost every single package in Tidyverse has cheat sheets, and we're gonna go there. We have package called reader, which goes with all the data imports. And as you see, we have read delimiters of any kinds, read CSV, CSV to TSV. You can write delimiters, TSV, CSVs, and so on. You have all parameters of these functions talk about. And here there is a read Excel package also explained with all the possible operation you can do. And if you use Google Sheets, for example, there is also a possibility to do it with the Google Sheets 4 package. And for example, if we are talking about ggplot, this cheat sheet is very, very useful. Oh, it's on the GitHub. So we can see all the geoms that we can use and what arguments they take in. We can also see how to work with coordinate systems, that we can face it for so-called multiple small multiples. We can define labels, legends, temps, for example, and if we have point geom, we can change this the shape of the point. They are very useful, and this cheat is not really very cheating. Yes, writing to and from Excel is really not really hard thing to do. What can you
can you export the chart that you created? Can you export it to Excel, or do you only export the data?
What do you mean, the chart with the plot?
Yes, that one. Yes. Can you export that to Excel?
You can export it to image or to PDF, or to clipboard and paste it in Excel. But there are packages that can help you with much more. Excel Connect, for example, I'm not using it because as I said before, I was using it like export and import only. But Excel Connect, for example, and OpenXLSX can be used for defining almost everything in the Excel. For example, it can be like replacing what was the language that is native in the scripts in the Excel. I forgot about it. The VBA.
Okay.
So we can place we can format cells in Excel. We can read formatting into the object in the R. So there are many things, but it's much deeper rabbit hole than we think.
Okay. There's Michael who is asking, do you provide tuition in R in places like Udemy?
I didn't thought about it.
Oh, okay.
But if you want to have have very robust place to learn about R, I would prefer rather Data Camp. that I was improving my skills there.
Okay.
They have hand-on exercises, not only the movies and texts.
Okay. So data camp.
Yep.
Okay. Okay. My question is, how many rows can RStudio handle? Does it have a limit of rows of data that it can handle?
The biggest data set I had here, and I used Spark for Spark layers, so it's Spark included in R, because it was over my capacity of RAM memory.
Okay.
It was 24 gigabytes of CSVs.
Wow, that's big.
So it was more than million.
Yeah, that's a lot. That's a lot.
Yeah,
of
but
yeah.
with normal data, I would say that the most common things I did was at about 2 millions to 10 millions at once.
Okay.
But it's most common things.
Okay. Okay.
It can be hard to read into view sometimes, but it's operating on it below with no problem.
Okay. You can be able to slice it into whatever analysis you want to do.
Yeah.
Okay. Time is not on our side. Anyone else with a question to Conrad? I think PK, you will have to reach out to Conrad on LinkedIn so that at least you can do, he can show you how to do forecasts using Prophet. Or will it take time for you to show us how to use the Prophet package?
If you would like if you would like me to do it, I can do little recording, or I can prepare the file with it for you to try it at your own computers, for example, whatever you would like.
Okay,
Because
I think
for now it's gonna be a little bit longer, because I was not using it for a few months, and just setting it up would last, for example, 15 minutes right now.
Oh, okay, okay. I think you can record and then you can share a link from your YouTube video, wherever else that you are going to upload it.
Okay.
Yeah. Anyone else with a question?
Well, thank you so much, Conrad, for this. This has been useful. I have known you for a couple of years, and it's really good to see you finally in a workshop. So just keep going. You've done a great job, and I love the material. And as for the speed for R, it's amazing. I've been using it for a couple of years. Definitely, you can see the benefits over Excel in most operations. Like a couple of days ago, I did 500,000 records with complicated calculations, and it was just a breeze. It was done in seconds. So thank you so much, Conrad, for this, and Crispo, and hope to see you again in another workshop.
Yeah, yeah. It's I'm also very interested. I didn't know it was this good.